Hello and welcome to today's class. For this class, we're talking about the second part of the study of components of an AC circuit. So last class, we did an introduction to AC circuits, right? And we said there are about three components there. So we have the resistor, capacitor, and the inductor. So to check out our first class on resistor, I'll drop the link above you here. So check above you here, you see a link to our first class where we discuss about the resistor. So today's class we're discussing about the concept of capacitor. All right, definition please. Definition please. A capacitor is a device used for storing electrical charges or electrical current or electricity. So we use capacitor to store electrical charges or electrical current or electricity. When it comes to the study of capacitor, note that the capacitor of a capacitant, right? So note that the capacitor of a capacitant is measured in farad. That is the unit. The unit for the capacitor of a capacitant is simply what the farad. So note that when it comes to resistor, the unit is what? Is ohms, right? Resistance is in ohms. While capacitance is what? Is measured in what? In farad. So the unit for capacitance is what? Is farad. So having defined capacitor and we have known the unit, the SI unit for capacitance, let's discuss the circuit symbol. So at this point, note that the circuit symbol for a capacitor is given below. The circuit symbol for a capacitor is given below. Whenever I see something of this nature, this signifies what? A capacitor, right? So observe the difference. For resistor, a resistor is something of this nature. This is what? This is resistor. This is capacitor. Now observe the difference between capacitor and a battery. For a battery, I have something of this nature. Observe, I have a short one and a long one. This is a battery, but this one are equal. The lengths are equal. So observe the difference, please. Don't mix them up. So that becomes the concept behind the circuit symbol for a capacitor, as you can see in front of you. All right, let's proceed from here. So now, when it comes to capacitor, we said the unit is said to be what? Farad. Why the circuit symbol is this? So at this point now, mathematically, the capacitance C of a capacitor is equal to the current passing through electric circuit over what? Potential difference. So where Q is called the electric charge, while V is called the potential difference, right? And C is called the capacitance. So I have this one here. So when it comes to capacitor, the mathematical expression for the capacitor of a capacitance is given as C to be equal to Q over V, as you can see in front of you. At this point here, let's discuss something called the arrangement of capacitor. Arrangement of capacitor. All right. When it comes to the concept of arrangement of capacitor, there are two distinct ways of arranging capacitor. Number one, there we have the series arrangement, and the second one there is called the parallel arrangement. All right, these are the two distinct ways of arranging capacitor, ranging from the series arrangement and the parallel arrangement, as you can see in front of you. Let's have the first one called the series arrangement. Let's have the first one called the series arrangement. When it comes to the series arrangement, definition please. A series arrangement is simply the end-to-end connection of a capacitor. So series arrangement of a capacitor is simply the end-to-end connection of a capacitor as shown below. Please draw this diagram, please. Draw this diagram. We said this is simply the end-to-end connection of a capacitor as shown below. So I have C1, C2, and C3. So this become what? A series arrangement of capacitor. So I have this man here as a series illustration of capacitor, as you can see. So at this point, note that the capacitor of a capacitant, okay. At this point, note that for a series arrangement of a capacitant, their equivalent capacitance. At this point, note that for a series arrangement of capacitor, the equivalent capacitance is given as 1 over C to be equal to 1 over C1 plus 1 over C2 plus 1 over C3. So this becomes the mathematical expression for calculating series arrangement of resistance. Of course, for our previous class, when we discussed resistance, right? We said when it comes to resistor, the series is not this. The series is in what? In straight form. That's R1 plus R2 plus R3. Observe the series here. Series becomes what? In a fraction form, right? So it means that the series arrangement for a capacitor is same thing as what? The parallel arrangement for resistor, right? That's the concept. So I have this man here as the mathematical expression for series arrangement of capacitor, right? As you can see here. All right. Let's take an example to further explain this concept. Example one. Two capacitor of capacitance 2 ohms and 3 ohm. Sorry, 2 microfarad and 2 microfarad and 3 microfarad. So I'm saying that two capacitor of capacitance 2 microfarad and 3 microfarad are arranged in series. Find their equivalent resistance. So I'm giving these two numbers here. These two capacitor, they are arranged in series. So find their what? Equivalent resistance. So far I'm here in series, right? So when it comes to series concept under capacitor, we know I'm taking it in fraction form. So that becomes 1 over C to be equal to 1 over C1 plus 1 over C2. I'm having just two value here. So C2. From here, 1 over C is equal to 1 over what? C1, that's 2, plus 1 over what? C2, that's 3. From here, I will have that 1 over C is equal to LCM here is 6. 6 in 2 is 3, plus 6 in 3 is 2. So I have 5 over 6. So I'm saying that 1 over C is equal to 5 over 6. Take them up back. I'll have C over 1 is equal to what? 6 over 5. So 6 over 1 is what? Is C. So therefore, C is equal to what? 6 over 5. So it means that the equivalent capacitor of this capacitant is given as what? 6 over 5. So this becomes the concept of series arrangement of what's it called? Of capacitor. Let's discuss second one called the parallel arrangement, please. Parallel arrangement. The parallel arrangement of capacitor. Let's discuss parallel arrangement of capacitor. Put down. This is the side-by-side arrangement of a capacitor as shown below. This is the side-by-side arrangement of capacitor as shown below. Draw this diagram, please. Draw this diagram. This is side by side arrangement of capacitor as shown below. Draw this diagram. Call here C1, C2, C3. When it comes to parallel arrangement of capacitance of a capacitor, I have this diagram here. So it becomes diagram for expressing a parallel arrangement of capacitor, as you can see in front of you. So note that for a parallel arrangement of capacitor, their equivalent capacitance is given as C to be equal to C1 plus C2 plus C3. This becomes the mathematical expression for calculating problems under parallel arrangement of capacitor, as you can see in front of you. So note that for resistor, last class resistor, for a series resistor and a parallel arrangement of capacitor are the same. Observe. While for a parallel arrangement of resistor is similar to what? A series arrangement of what? Capacitor, because they are brought in fractional form, while the other one is brought in what? In just in a straight form, in a linear form, this way, as you can see in front of you. Let's take an example to further explain parallel arrangement of capacitor. Example. All right, let's use the concept. So, all right, let's explain the concept behind what's it called? Explain the concept. All right, let's explain the concept behind parallel arrangement using some example. So let's say I have 2 microfarad. Let's say I have 4 microfarad and 10 microfarad. These 2 capacitor of capacitance are arranged in parallel. So I'm going to find their equivalent capacitance. What do? Simply add them up. So we know that C is equal to C1 plus C2. So therefore C is equal to what's C1? That's 4 plus what's C2? That's 10. So therefore my C is equal to what there? 14 microfarad. So my answer there becomes 14 microfarad. This is over 5 microfarad, please, because said capacitor, the unit for capacitance is what? Is farad. So I have this concept here using the idea of series and parallel arrangement of capacitor. Let's discuss one last thing and end this concept. Alright, let's discuss the energy stored by a capacitor. So note that the energy stored by a capacitor is also called work done by a capacitor, right? So mathematically, the work done by a capacitor, or perhaps the energy stored by a capacitor, is equal to half QV. So this becomes the mathematical expression for calculating the work done by a capacitor, or perhaps the energy stored by capacitor, as you can see. So this becomes the first formula for calculating work done, right, under capacitor. So note that the unit is what? In joules. So the unit is what? Is measured in joules because it's work done, right? So at this point here, let me derive other expression, right? So but from here now, but we said that C is equal to Q over V, right? Make Q subject. I'll have that Q from here. Q is equal to what? CV. So now I see Q, I'll put CV. So from here, we say that W now is equal to half. What is Q? Q is CV now. Half CV, then this V, yeah? Multiply this through, I will have that W is equal to half C, V times V is V squared. So this becomes another mathematical expression for calculating work done by a capacitor. So half QV or half CV squared. Now let's take a look at another expression again for calculating work done by a capacitor. We said again that, but we said that C is equal to Q over V, right? Let's make V subject. Therefore, V is equal to Q over C, making V subject Q over C. Anytime I see V, I'll put Q over C. So from here again, so from that point here, alright, from this point here, I'll have that W is equal to half Q. What's V? V is Q over V. That's into Q all over C. From here, I'll have that work done by a capacitor is equal to half Q times Q is Q squared all over C. So this becomes another mathematical expression for calculating capacitor, or perhaps the work done by a capacitor, ranging from the half QV or half CV squared or half Q squared C. So I have this one as the expression for calculating work done by a capacitor. So in the next class, we'll discuss about the concept of inductor. After inductor, in our next class, we'll talk about several past questions based on resistor, capacitor, and inductor. See you in our next class. Do well to join our WhatsApp group. I just created a WhatsApp group so to further communicate ideas with other students from several countries. If you are interested in the WhatsApp group, simply check the description of this video. I'll drop a link there to the WhatsApp group. So see you in our next class.